Gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 2, Learning Target 6 Notes. So we're going to be talking about solving systems with substitution using multiple steps. So this is taking what we did on the previous note sheet and we're going to be adding another layer to it. So let's go ahead and let's take a look at the infinitely many solutions. So if both variables are going to cancel out and what's left over is a true statement, then the system has infinitely many solutions. So let's say both your letters end up canceling out when you're going through the algebra and you have something like 6 is equal to 6 or 2 is equal to 2. If what's left over is a true statement, then you have infinitely many solutions. Now, if what's left over is a false statement when they cancel out, then you have no solution. So if you have something like 0 is equal to -9 or something to that effect, then it's a no solution scenario because it is a false statement. So let's go ahead and let's take a look at some times when we would use this. So let's start by doing the substitution on number 1. So I see that this is already solved for x. X is equal to this 2y plus 2. So where I see x out here, I'm going to substitute it out. So what I'm going to do is I'm going to take x out completely and I'm going to put 2y plus 2 in the place of x. So then I end up getting this scenario right here. So all I did was substitute out just the x. So now I'm going to take and distribute in the 3. 3 times 2y is 6y. 3 times 2 is going to give me 6. Now here I'm going to have a minus 6y, and that's equal to 6. That's a lot of 6's, okay? So what I'm going to notice is 6 minus 6y is going to cancel out. So when they cancel out, I'm left with 6, and that's going to be equal to 6. So 6 is equal to 6. Now that's a true statement. 6 is going to equal 6. So that's infinitely many solutions. And I don't like writing all of infinitely many solutions out. So I just write that as IMS. Okay, let's take a look at number 2. So for number 2, I see that y is equal to 2x minus 7. So where I see y in the second equation, I'm going to substitute that out. So I have 6x minus 3. Now instead of the y, I'm going to put 2x minus 7, and that's going to be equal to 24. So let's go ahead and let's solve this algebraically. So I'm going to start by distributing in the -3. So -3 times 2x is a -6x. -3 times -7 is going to be a positive 21. Now remember, when you multiply two negatives, it becomes positive. So 6x minus 6x is going to cancel out. And then what we're left with is 21 is equal to 24. Well, that's never going to be true. So that's a false statement. So this one is no solution. So you can write out no solution if you want, or you can abbreviate it as NS. Either is A-okay with me. Next, let's take a look at steps for solving systems using substitution. Now, this is going to have an extra layer than what we did on the previous note sheet, so I want you to make sure you write that down as well. So, taking a look for the first one, solve one of the equations for one of the variables, okay? So that's not going to be given to us like it was before. The next part, substitute that expression into the other equation. The next part after that, solve for the remaining variable, substitute that value in, and solve for the other variable. Steps 2 through 4 are what we did on the previous note sheet. Number 1 is the only step that is new. Okay, so let's take a look at practicing some of these, starting with number 3. So in order for us to graph these, we need to have it solve for one of the variables. So I want to pick which one is going to be the easiest to solve. So what I want to look for are letters that are positive that don't have a number in front of them. So like that X there. Letters that are positive that don't have a number in front of them. So what I'm going to do is I'm going to take this X plus 2y is equal to 15, and I'm going to solve it for X. So when I do that, I get minus 2y on both sides. So I get that X is equal to a negative 2y plus 15. So negative 2y plus 15 and x are the same thing. So now I can plug it in for x up top. Now notice I make sure I plug it into the other equation. This equation here and this equation are the same thing. So when you substitute it back in, you need to make sure that you are substituting it back into the same equation. So let's go ahead and we're going to take that x out. So I'm taking x out completely and I'm putting 2y plus 15 in instead. And this should actually be an equal sign there for you on there. And that's minus 3y is equal to 2. And we'll do a positive 2. Okay, so what we're going to do now is we are going to solve this for y. So the first thing I'm going to do is distribute in that 2. 2 times negative 2y is a negative 4y. 2 times 15 is 30. And then the minus 3y isn't going to be multiplied by the 4. It's just going to kind of stay there. So now we're going to take 4y minus 3y, which is going to give us y plus 30 is equal to 2. I'm sorry, negative 7y when I add those together. Goodness, they're both negative, so that would be a negative 7y. So now I'm going to go ahead and subtract 30 from both sides. So I get negative 7y is equal to negative 28. So now that negative 7 is being multiplied by the y. So to get it over to the other side, I need to divide both sides by y, and I get that y is equal to 4. So y and 4 are the same thing. So now I need to substitute that back in to get my x. So when I go back up to the original problem up here, I could plug it into either one of these, but you can also plug it into that one, and it actually doesn't matter. I suggest plugging it into this one because it's already solved for your x. It saves you some time, but really it doesn't matter which one you plugged it in for. So now I know that y is equal to 4. So from that solved equation, I'm going to take y out completely and put 4 in instead. So then negative 2 times 4 is negative 8 plus 15. Well, negative 8 plus 15 is going to give me 7. So then when I put those as a coordinate point, first I write my x and then I write my y. So 7, 4 is my final answer for number 3. Now, let's take a look at number 4. Again, I want to find one that's easy to solve for. And for me, I think it's going to be easiest to solve for that x because no coefficient and it's positive. So what I'm going to do is I'm going to take x minus 3y and I'm going to solve it for x. So I'm going to go ahead and add 3y to both sides. So there I end up getting that x is equal to 3y. So that's what the second equation is solved into. So then when I get that first equation, I'm going to plug that in. Again, you want to make sure you put it in the other equation. So now I'm going to rewrite that equation out. Everything is going to stay the same except instead of having x, I'm going to put 3y in instead. And I can do that because x and 3y are the same thing. So then I get 7y is equal to 26 plus 33y. Now I need to get that 33y over to the same side as the 7y. Well, since that's positive, I'm going to subtract 33y from both sides. So I get negative 26y is equal to 26. Divide both sides by negative 26, and I end up getting that y is equal to negative 1. So since y is equal to negative 1, I have a couple of options for where I plug it in. Okay, I could plug it in here, or I could plug it into either one of these. Again, this equation right here is already solved for x. That makes it easier. So I'm going to put it in there. So I have x is equal to 3y. Well, instead of putting in the y, I'm going to put in the negative 1 because that's what x is equal to. So then I get negative 3. And now I need to write that as a coordinate point. First I write my x, and then I write my y. So I get negative 3, negative 1 for number 4. Taking a look at number 5. So for number 5, it's actually already solved for a letter, so we don't have to go through the work of doing that. Y is already set equal to 4 plus x, which means we can instantly go into using substitution. So I'm going to go ahead and plug that in for y up there. So I have 4 plus x, and then minus 3x is equal to 4. So when you substitute out the y, you keep everything else in the equation the same. So now I need to combine my x terms. So the 4 will stay the same. X minus 3x is going to give me a negative 2x, and that's equal to a negative 4. So now I need to get that 4 over to the other side. Since it's positive, I'm going to go ahead and subtract 4 from both sides. So I get negative 2x is equal to a negative 8. Then I'm going to divide both sides by a negative 2, and I get that x is equal to 4. So now I know that x is equal to 4. So if I go back up to the original equation, I can plug in 4 there, or there. Well, I noticed that second equation is already solved for y, so that's going to make it a lot easier to substitute it in. So I have the equation y is equal to 4 plus x. So what I'm going to do is I'm going to keep the 4 in, and then instead of writing x, I'm going to write the 4, since I know that x is equal to 4. Well, 4 plus 4 is going to be 8. Okay, so first we're going to write our x coordinate, then we're going to write our y coordinate. So the point is 4, 8. Now let's take a look at number 6. So for number 6, I want to solve for a variable. So I would suggest either solving for this y or for this y, because both of them don't have a number in front of them and they are positive. Well, let's just solve that first equation for y. So negative 4x plus y is equal to 6. So in order to solve that for y, I'm going to go ahead and add 4x to both sides. So then I get that y is equal to 4x plus 6. So that means y and 4x plus 6 are the same thing. So now I'm ready to substitute that in. So where I see y out here, I'm going to substitute that y out. Okay, and again, you want to make sure you plug it into the other equation. So I have 4x is equal to 7 plus y. Well, instead of putting in the y, I'm going to put in 4x plus 6 instead. Well, when we're adding, a lot of students make the mistake of distributing in that 7 like we're multiplying, but there's a plus sign here. So really, this is just 7 plus 4x plus 6. So let's go ahead and let's add those together. So I get 4x is equal to 7 plus 6 is going to give me 13. So I'm going to get 4x plus 13. So now I need to get my 4x's on the same side. So I'm going to subtract 4x from both sides. Well, when I do that, those guys cancel out. And I end up getting 0 on this side is equal to 13. Well, is 0 ever going to equal 13? No. So that means that there is no solution, or NS, for number 6. Let's take a look at number 7. So I need to solve this for a variable. And again, I'm looking for one that doesn't have a number in front of it that's positive. So I'm going to solve for that y there. So I have negative 4x plus y is equal to 6. So to solve for that y, I need to add 4x to both sides. So then I get y is equal to 4x plus 6. So 4x plus 6 and y are the same thing. So y is equal to 4x plus 6. So where I see y up there, I'm going to plug in that 4x plus 6. So I need to be really careful when I do that. So I have negative 5x minus the entire thing of 4x plus 6. Now we'll talk about what that means here in a second. All right, so let's go ahead and let's take a look. So you see how you have this negative on the outside. So that means there's kind of like a negative 1 on the outside of this parenthesis. We need to remember to change the signs of everything. So we have negative 5x, negative 1 times 4x is negative 4x, and then minus 6 is equal to 21. So now we need to combine our x terms. Negative 5x minus 4x is negative 9x. Minus 6 is equal to 21. So then I need to go ahead and add 6 to both sides. So then what I end up getting is negative 9x is equal to 27. Well, I'm going to solve for x, so I'm going to go ahead and divide both sides by a negative 9. 27 divided by a negative 9 is a negative 3. So now I know that x is equal to a negative 3. So when I go up here, I can plug that in here, or here, or here. Again, I went through the work of solving that equation right there for y, so to me that makes the most sense to substitute it back in. So I'm going to go ahead and do that right now. So I'm going to use the equation y is equal to 4x plus 6. Now, instead of writing x, I'm going to put in a negative 3 because I know that's what x is equal to. And the rest of the equation will stay the same. So y is equal to a negative 12 plus 6. Well, negative 12 plus 6 is a negative 6. So then my solution is negative 3, negative 6. Remember, your points go first your x and then your y. Okay, let's take a look now at number 8. So x is equal to y minus 9. So where you see x up here, we can take y minus 9 and put it in. We don't have to do any solving. So we have y minus 9. Now that's taken the place of the x. And everything else is going to be the same, and that should be equals 5. Okay? So let's go ahead and let's solve this. Y plus y is going to give me 2y minus 9 is equal to 5. Then we're going to add 9 to both sides. So I get that 2y is equal to 14. Then I'm going to divide both sides by 2, and I get that y is equal to 7. So y and 7 are the same thing. I can plug it in here, or I can plug it in here. Notice that this second equation is already solved for x, so that's going to make it a lot easier. So I'm going to take the equation x is equal to x minus 9, or y minus 9, sorry, and I'm going to put in 7 for that y. So then I get 7 minus 9 is equal to negative 2. So then I need to write that out as the coordinate point. First my x, and then my y. So that concludes your note video for today. Please make sure you are asking questions on this because it can be challenging. Thank you for listening.